Now we have our problem, which we can see is a linear decay problem. Now, using this information, we can create recursive rules and explicit equations. Now that we have our information, our start and initial value, which is 21 million, and our rate of decay, which is 3 million, we can put it into our equation. For m, we will use the rate of decay, which is also the slope, making it negative to show decay. Now we'll use our start or initial value as our y-intercept, which is 21 million. We also need to make a recursive rule. Let's push this. Now, with the same information, we're going to make a now next or a recursive equation. Here's our equation. Notice that our rate of decay or slope is affecting now, creating next, and that our start value is also our start and initial value or y-intercept. Now that we have our equations, we can make a table of values, and from our table of values, we can make a graph. Here is an already filled in table of values. However, by taking the x number and placing it into the equation as x and solving for y, you can find out what y is. In order to make the graph, we need to take our ordered pairs and place them as plotted points on a plane, a coordinate plane. Here's the graph. You can see, though, where the ordered pairs would go. There, 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 and there, to make a line showing that it is a linear graph, and then because it is traveling downwards from left to right, it is decay. And finally, we can use our tables and graph or equations to solve the problems given to us. Now here is our problem. If a person stops taking the drug after 3 weeks, how many viruses would still be alive? And then after how many weeks would the virus be gone? We can actually plug both of these into our equation. For problem 1, the plugged-in equation would be y equals -3 times 3 plus 21 with the multiplication in parentheses. Once solved, the equation would be this. So that means that there would be 12 million viruses left after 3 weeks. We could have also looked at our table of values and seen that after 3 weeks there would be 12 viruses left. For our second problem, we can also do that. See, after 7 weeks, there are 0 viruses left. We can also solve it with the equation. Because we are looking for our x value, we want to plug our y value, 0, in and put -3x plus 21. which is our equation with the plugged in y. And now we solve. Once solved, the equation would be this. Now we know that after 7 weeks, there will be 0 viruses left. Thanks for watching part 2 of my project, linear decay. This problem was linear decay by Claire Johnson.